Hello, I am Syntax Sugar, and today we'll be looking over the game theory's problem on the main dilemma, commonly known as prisoner's dilemma. So, imagine two criminals are caught and interrogated separately. The police don't have enough evidence, so they offer each a deal. If one betrays the other while the other stays silent, the betrayer goes free and the silent one gets 10 years. If both betray each other, they both get 5 years. If both stay silent, they each get 1 year. So I ask you right now, what do you think would be the rational move for the prisoner to take? Okay, so naivety. Your first thought will usually be that, of course, I know my friend and I know my comrade, and he will stay silent, and we'll both get 1 year off, and that minimizes the total punishment. So it isn't wrong to think so. But do you really believe that your friend will not betray you? Because if they do, they only get no years. They leave scot-free. So would being silent be a good choice? So we can look at the payoff matrix. And this payoff matrix is a kind of thing used in game theory to summarize a problem. So we usually like to use Alice as A and Bob as B. And you can see both of them have two choices, to defect or to conspire with each other. And if both conspire, they get 1 year and 1 year. So that's the best outcome for both of them, only getting 2 years in total. And the rest will lead to 10 years in total. So imagine I'm Alice, and I know that Bob's gonna defect. Would I rather get 5 years or would I get 10 years? If he defects, I'm gonna defect too. But if he conspires with me, I'm not gonna conspire too because I can get 0 years by defecting. So it's an optimal strategy to the defect. It's a better or equal outcome than conspiring. So this is what game theorists call a dominant strategy. So the paradox is when both Alice and Bob follow this rational reasoning, they lead to a worse collective outcome of 5 and 5 years because both of them are going to defect always, and that's worse than cooperating, which will be 1 and 1. So some ideas are best shown through a simulation because it really does seem unbelievable. So I want to explain the code beforehand. We have three strategies, which is random choice. It just chooses randomly between one of them. It always defects and it always cooperates. And if we're gonna run this for 1,000 rounds, and we're gonna see each return and how it's gonna play out. And if you can see here, we have the probability that both, or sorry, the average payoff that when both they both defect is 5.0, 5.0, and one defects and one cooperates is 10 to the one that defects always, and the random strategy actually gets a good mix of them. And to wrap up, really, the prisoner's dilemma really shows how individual rationality can lead to a collective failure because it's just a show and a display of how greed can be bad sometimes. And it's more than a puzzle because it explains real world problems in economics, politics, and even climate change negotiations. And it's even found in nature where two birds have to fight over food. Is it better to fight over them, fight over the food and try to get it, or to run away and or to share? So finding ways to encourage cooperation and to leave kind of this state of the prisoner's dilemma and to leave the setup of the problem is what people try to do. And I ask you the question, Imagine if this dilemma were repeated between two players over and over. What strategy would be the best? And in the end, I thank you for listening.